Thank you. Can everybody hear me? Okay, good. I'm the shortest one at the microphone today. So the topic for this session talked about discussing the changes, the results, the technologies, and the management impacts of digital transformation. And my area is a little bit different than anything I've heard about so far at the conference. I'm actually going to speak to the engineering process, or as we call it, the EPCOM process. So internally to Eastman, we're actually transforming our EPCOM process through digital innovation, and that's what I want to share with you today. Excuse me. Hopefully, I will share that with you today. There we go. So a little bit about Eastman Chemical. If you're not familiar with us, we are a specialty chemicals, specialty materials manufacturer. We're headquartered in Kingsport, Tennessee. It's a picture of our corporate headquarters there. We're a Fortune 500 company. As of last week, I can tell you we're a greater than $10 billion revenue company. We're a global manufacturer of specialty materials, specialty chemicals. We've got over 50 sites for manufacturing around the world, and a global team of over 14,000 individuals that are working at those sites, based out of 100 countries around the world. That would be the wrong way. Okay, we're good. I've got it now. If you're not familiar with us, some of our products, you've probably touched at least several of our products today. You just don't know it. We make a product called SafeLux that goes in the windshields of automobiles. It's a safety product, keep glass from coming in, you from going out if you're in an accident. We make Triton polymers. They're BPA-free polymers. They're in the sports bottles that you'll use. We make plasticizers. We make acetate yarns. A lot of you are wearing those today. So a host of products. We make products that go into the automotive industry, tires, paints, coatings, that all go into the automotive industry and the building industry as well. We make building films that you see on large skyscrapers in larger cities. So those are some of our products if you haven't heard of us before. And what I wanted to talk with you today about is our continued journey of innovation. So our facility was started in Kingsport, Tennessee. George Eastman founded it right after World War I because he needed an alternative supply stock for the chemicals to develop film, and that chemical primarily being methanol. So we've got a long history of innovation. The mountains of East Tennessee were probably a long way for George to come from New York. And he started out with a construction project there on the banks of the Holston River, building a methanol project. So here, some 100 years later, that's what my presentation's about, how we're innovating that construction engineering process to bring new facilities to life. So the EPCOM process, if you're not familiar with that term, it's an acronym. Engineering, procurement, construction, operations, and maintenance. Those are all the stakeholders that go into bringing an asset to life. So when we think about first of all, we think about a new product. In order to produce that molecule, we have to have a plant, a chemical facility that actually produces that molecule. That chemical plant facility is made up of assets. That's how all those assets come to be. They go through an engineering process. Our procurement organization's involved to buy the materials, buy the supplies. Construction actually executes, fabricates it, and then we've got operations and maintenance input throughout that life cycle, and ultimately there's a handoff to them because they're going to own and operate it. So what that process looks like today, it's a very stringent, very rigorous process, very data-driven, because we want to get it right and we want to make sure it's safe. So after that idea has been had, we start pulling data sheets out of the file cabinets. We're much more modernized than that. We don't go to the file cabinet anymore. We've got those on our computers. Turns out that's a great step backwards because everybody's able to tweak their Excel file on their computer. So when it was in the file cabinet, it was great. We had design fields, very, very stringent structure. When we went to the Excel sheets, we lost some control of that. Then we start talking to outside suppliers, our OEM suppliers of equipment. What can they provide? They transfer all that data to their paper. Ultimately, when the project gets approved, we start working with a detailed engineering firm off-site. We hand all of that information off to them. They're used to working in their processes. They transfer it over to their paper. All of this is electronic paper nowadays. We go to construction, there's still questions, still issues to be resolved. So again, this massive exchange of information. And it goes all the way out until you get to commissioning and startup of that facility. And the poor person who's out there in the field at 2 a.m. trying to start this up has 15 different sheets of paper telling them 15 different points of data, and they're having to go all the way back through the life cycle to figure this out, or they're having to make an educated guess, which that's not really what we want them doing at 2 a.m. And at the end of the day, it lands with the people who are going to own and operate the facility as a disorganized compilation of all of this data. So every USB drive you see on that chart is an exchange of critical data, critical information to bring this process to life and ultimately to be able to operate that manufacturing facility. So that's a lot of little USB drives. Seems like a lot, but to give you a little bit of context, an average chemical project, an average capital project, think low double-digit millions, we had over 15,000 documents issued on transmittal. That's 15,000 final documents, and you can tell there how that's kind of broken down, 4,000 vendor documents, 2,000 instrument specs, 2,000 drawings, isometrics, and so on. That does not even include the upfront work we did on the front-end engineering deliverables to supply to that detailed engineering force to create those 15,000. That doesn't include our procurement documents. That doesn't include our project controls documents. That also doesn't include calculations, exchanges of information. So you can see how 15,000 very quickly becomes 5 or 10 times that number. So 15,000 is 75 or 150,000 document exchanges. A lot of information going back and forth. It also doesn't give us the capability, the system that we've had in place, to catch errors. It's hard to find an error in that much paper and in that much documentation. It's hard to make a change. We don't like to make late changes, but sometimes it's not a change, it's an enhancement. And if we can capture that before we actually build the facility, we can bring a better facility to life. We don't have the system to do that. So that's our existing process. We wanted to make it better. If we can make it better, we can get the right information to the right people at the right time. We have the ability to optimize communication with all of the stakeholders who are involved, let them have the right information, let them make the right changes. And we also have the capability to automate all of those little USB drive exchanges that you saw. We're able to take work out of the system and make sure that that project's successful on time and on budget. So our in-house name for this effort is Sega. Sega is an acronym, so I'll explain that in just a second. But Sega makes our EPCOM process better, stronger, and faster. It makes it better with accurate, reliable access to the data that's needed. Makes it stronger that we are able to link that data, automate those workflows, and it makes it faster that anybody who needs it can have real-time access to vendor data, EPC contractor data, and we can actually bring our project to life faster. We can take that idea to finished facility faster and put that end product in the consumer's hand faster, which is great for our company, but it's also great for end consumers because we're making things that have a tangible benefit to them and make their lives better. So to sum all that up, today our conceptual innovators and our project teams have this idea of the masterpiece when they start working on this project. The systems we have had in place allow us to chop that up and hand it off like a box of jigsaw puzzle pieces. And our execution forces and our manufacturing groups that are going to own that are kind of left putting together the masterpiece as best they can. What our Sega platform does is allows us to convert that masterpiece vision to pixels. We're able to allow those pixels to be automated, to flow back and forth freely. Anyone in the life cycle of that asset can have access to that information at any time, and so everybody involved realizes that masterpiece. So I told you I'd explain Sega a little bit more in a minute. It is an acronym, and we started in earnest on this about 4 years ago. And at that time, Sega meant Seamless Engineering Information Global Access. Having all of the information available to anybody who needed it anywhere in the world, transparent data. And if you were in the last session, Greg asked a question about digital disruption. So we have already seen this disrupted. That was a noble concept, and that was space age to us 4 or 5 years ago. We've done that. We've created that, and I like the term that was used earlier about data lakes, because I hate to use databases. It's not a database. We have all that data captured electronically. It is transparent, and all those stakeholders can see it. So it's time to go to the next level, and we wanted to make sure our internal stakeholders knew that something disruptive was getting ready to happen to their work processes. So I got a short video I hope to show you, apparently without sound. It's much more poignant with the sound. So you'll have to trust me with the sound all the way through it. It really gets the point home. Cartoon music at the front and a little livelier music there at the end. Hopefully you did pick up, since you had to read, we changed the name of the acronym to be more meaningful for what we're actually doing right now. Sega now stands for Seamless EPCOM, capturing all the stakeholders, integrated, everybody's got access, and it's now automated and it's integrated global access. Seamless EPCOM integrated global access. Again, single point access, but it is integrated and it is automated and it is changing how we do work. So all the elements of that EPCOM process are included within the Sega concept, taking manufacturing assets through, or taking engineering concepts through that process to create manufacturing assets. So the first question I always get asked when I talk to some of our other internal stakeholders is, well, how does it work? I will tell you conceptually how it works. I will not go through the 4-hour coding background description, but how it works in general, if you'll start at the upper right-hand corner, I don't think I have a pointer. Oops, that was not the pointer. Okay, that would be the pointer, better button. We start with an asset that's going to go into place in the field. We have a data digital asset catalog now that models that asset as a digital image. It's dimensionally correct, looks like the asset in real life. We have a data-centric environment where we can document all of the meaningful attributes for that piece of equipment. We can put those into an integrated 3D model. And really, this is leading to our smart drawings. The idea is once you have all this information in that model, you can click on it and you get all your pertinent and needed data. Now that we've got all of that compiled and together, we're able to automate a lot of those EPCOM processes. We've already been able to automate drawings. We're able to create automated P&IDs, automated loop sheets, loop diagrams from that data and from that model. We're able to generate automatic PRs, purchase requisitions. We're able to go straight from our data sheets to having SAP spit out a purchase rec straight to our vendor with no human interaction. So that was a huge step change for us and a very labor-intensive process before. We're able to automate material takeoffs. We're able to go straight to that model and pull those materials off into a bill of material, again, without having to have somebody go through and introducing the opportunity for human error. Our next steps that we're working on now, advanced work packaging. We're electronically generating those packages without human interaction again, downloading those from the models, being able to create those automatically, being able to do automated fabrication, send fabrication files direct to the machine, and ultimately automated field installation packages too. At the end of the process, we're able to provide project dashboards. The project manager can see all of this data as it's coming to life. We're able to provide a seamless handover to operations and to maintenance. Instead of at the end of the project, in the old days they got a box of paper, now they've been getting a SharePoint file full of data. They're now having this go into the systems where it will live, where they'll be accessing it to operate and to maintain. It's seamless. They're not having to load it. It's right where they're going to see it, and all of that happens automatically. So that's a little bit how it works. I don't have the file to show you here. There's a whole lot of software behind this. Interoperability is key to us to be able to make these changes and be able to make them quickly. We didn't want to move people out of their native systems and have to retrain broadly. So we tried to leave basic processes in place. We have new platforms in some areas, but we've tied our legacy systems to those new platforms and created our own in-house coded interoperability. So here's just kind of a sketch without naming all the different softwares that go in, but all of the different systems that are tied together, our procurement system, our ERP system, our advanced work packaging system, all of these different things that exist today, and the hexagons that are kind of holding out there are future iterations. We're also, it's a future iteration, but we're also looking at modular engineering, modular fabrication. We can now create skids of design within the computer system. For example, a centrifugal pump. Instead of having to put a pump and all the associated valving and piping with it, we can have that as a model item. We can drop that into the model. It saves time for the experienced designer. They don't have to create all that every time they have that design to take place. If you're a newer person in the organization, it also reiterates your training. You're not having to do that from scratch, and you've got that ready to go. Likewise, that can follow all the way through to field installation and fabrication. Instead of having to assemble all those pieces individually in the field, having a very highly skilled craftsman group in the field, we can do that at a third-party shop, and we just need to actually wire it up once that skid is set. So it gives us a lot of opportunities for flexibility and optionality. At the end of the day, I can talk a lot about what we're doing within our engineering organization, and there was a gentleman in the last session from our operations group. I can do that all day long. He doesn't necessarily see that. All he sees is he getting that information in that plant that works at the end of the day. How individuals see this, our engineering team, our procurement team, our construction team, and ultimately our manufacturing team, is we've got one portal. We've got our Sega integrator page where all of those entities can go in. They can see that data anytime they need. They can do drawing searches. They can do asset searches. And they're getting those dashboards real time. It's progressing their projects. It's showing productivity on the project. It's showing advanced work packaging progress. So all of that's available in a one-stop shop. They just have to open that one window and they're ready to do their job for the day. So for us, Sega is an essential element to efficiently executing capital projects, being able to bring products to market faster, and it is a digital disruption for our organization and how we do work. People's jobs are changing. There's things that they used to do, they don't have to do. It's automated now, and they're able to focus on the details that are important and be able to get those things right. So Sega is our platform for that effort, and I appreciate you letting me share it with you today. And I started out with a picture of our corporate headquarters. I'll end. Our corporate headquarters is located here, too. This is our facility in Kingsport, Tennessee, our manufacturing facility. 1,000 acres of manufacturing space there nestled between the mountains. The other thing that Sega does for us is it keeps our facility there very safe. We're able to have accurate data. We're able to have access to that data instantaneously so we can maintain the safety of this facility as well, which is hard to do when you've got that much manufacturing in one place. And this is a technology advancement too. This picture was made by a drone. We'd probably never have been able to get an airplane in that location at that time of day before. So a unique shot that the digital evolution has allowed us to have. Thank you.